So, when you think about cybersecurity, what's the first thing that comes to mind? For a lot of people, it's this image of a single, massive firewall, a giant digital wall. But the reality? It's way more sophisticated than that. Modern cybersecurity is actually a deep, multi-layered defense system, built from the ground up, piece by piece. And today, we're going to peel back those layers, one by one. We'll start way up high, at the 30,000-foot view with international law. Then we'll zoom right into the corporate boardroom to see how security programs actually get designed. And finally, we're going to get our hands dirty and see how those defenses are really tested. Okay, let's get into it.
So our journey starts with the rules of the game, and just recently those rules got a huge update. We're kicking things off with the European Union's NIS2 directive. This is a massive piece of legislation that's setting a whole new, much higher bar for cybersecurity all across Europe.
So, why the big change? Why a whole new law? Well, the directive itself tells you everything you need to know. This quote gets right to the heart of it. Threats are just getting bigger, smarter, and they're happening more often. The old way of doing things, it just wasn't cutting it anymore for the systems we all depend on. This isn't some theoretical problem. This law is a direct answer to a very real and growing danger.
So what exactly is NIS2? Honestly, the best way to think about it is like a new, much stricter building code for our digital world. It's a law that stretches across the entire EU, and its whole purpose is to make sure that the companies running our most critical services are all meeting the same high standard of security. It's a total overhaul of the old rules to deal with today's threats.
And this new building code, well, it covers a lot more ground. What's so interesting here is just how much the scope has expanded. The law breaks things down into two main categories. You've got essential entities, which are the big ones you'd expect, right? Energy, banking, all that stuff. But look at important entities. This now covers things like postal services, waste management, and even food production. We're talking about the services you rely on every single day, and they're all now under this digital shield.
And on top of that, here's one of the most critical changes in NIS2, a new laser focus on the supply chain. See, in the past, a company was pretty much just responsible for its own security. Not anymore. Now, they're on the hook for the security of their partners and suppliers too. And this quote just nails the new reality. The directive basically says companies have to check out the security of their suppliers. Why? Well, because your digital shield is only as strong as its weakest link. A hacker doesn't care about your super secure front door if they can just walk in through a supplier's unlocked window. This forces everyone to share the responsibility for security, all the way down the line. Okay, so we have the law, that's the what, but that brings us to our next layer, the how. How does a company actually take these high-level legal rules and turn them into a real working security program? Let's zoom into the corporate level and find out. You know, this is the exact question that keeps chief information security officers up at night. You can't just go out and buy a box labeled compliance. You need a plan, a framework, kind of like an architectural blueprint, to build your defenses in a way that's logical and covers all your bases.
And a really common playbook for this is something called the Trust Services Criteria. It's a framework that takes all the complex stuff in cybersecurity and organizes it around 5 core principles. Is the system secure from outsiders? Is it up and running when you need it? Does it process data the right way? Is secret info kept secret? And is personal information handled correctly? It gives companies a super clear, structured way to build and measure their digital shield.
Now, those last 2 points, confidentiality and privacy, they get mixed up all the time, but the difference between them is really, really important. See, confidentiality is broad. It can apply to any sensitive info, like a company's secret formula or their 5-year business plan. Privacy, on the other hand, is super specific. It only applies to personal information about you and me. It's not just about who can see the data, but the whole life cycle, how it's collected, used, and eventually gotten rid of.
All right, we've seen the law and we've seen the blueprint. But you know, building a shield is one thing. Knowing it'll actually stop an arrow is something else entirely. So now we're zooming into the most hands-on level of all, the reality check. How do you find the weaknesses before an attacker does? You can't just cross your fingers and hope for the best. You have to actively test your defenses. You have to pressure test them under real-world conditions. And this is where we get into the really cool world of ethical hacking. And there are basically 2 main ways to do this. First, you've got overt or white hat testing. This is done with the full knowledge of the IT team. Think of it like a scheduled building inspection. The whole point is to do a deep dive and find every single potential crack. Then you have covert testing, where the IT team has no clue it's a drill.
This is the surprise fire alarm. The goal isn't just to find flaws, but to see how the security team actually reacts in real time under pressure.
Now, this kind of testing, which is often called a penetration test, it isn't chaos. It's a highly professional, methodical process. First is planning. You set the rules of engagement and get formal sign-off. Then comes discovery. You gather intel on the target, kind of like a detective, looking for weak spots. Then you have the attack phase. You actively try to break in. And finally, and this is the most important part, reporting. You document everything you found and give them a clear roadmap on how to fix it.
To make this more concrete, let's look at one specific technique from that attack phase, password cracking. When you set a password, a system doesn't store your actual password. It stores a scrambled version called a hash. Password cracking is the art of trying to match that hash. Testers use automated tools to do this. A dictionary attack will try millions of common words. A hybrid attack adds numbers and symbols to those words. And a brute force attack, well, it just tries every single possible combination. It's an incredibly powerful way to find out if weak passwords are a crack in the shield.
Okay, let's zoom back out. We've gone from international law to the corporate blueprint all the way down to hands-on hacking. Now let's see how all these pieces fit together to form that single, strong digital shield.
And here it is, the complete picture. At the macro level, the highest level, you've got the law. NIS2 is like a national building code. It sets the minimum safety standards everyone has to follow. Then, at the meso or middle level, you have the blueprint. The trust services criteria are like the architect's plans for building a strong, logical structure. And finally, at the micro level, you have the test. Here, guidelines from bodies like NIST in the US detail exactly how to run these tests. They're like the building inspector, stress testing the final construction to make sure it's truly safe.
So why does any of this matter to you? Because this layered system, this whole combination of rules and blueprints and tests, this is what's protecting the fundamental services of modern life. It's what keeps your bank account safe, what keeps the lights on, and what keeps your hospital's data secure. It's the hidden architecture of trust in our digital world.
So this approach creates a really formidable digital shield, one that's stronger and more resilient than anything we've had before. But it does leave us with the final question. As the attackers get more and more sophisticated and technology just keeps changing at a crazy pace, is building an ever stronger, more compliant shield enough, or does the future of security lie somewhere else entirely? Definitely something to think about.